Simulating direct air capture, or DACCS, in En-ROADS. This is one method of carbon dioxide removal. I'm going to show you three things. First, how big is this industry likely to grow given various assumptions? Secondly, how much is it going to help the climate in those scenarios? And then third, what are the other effects on other parts of the system, like how much it costs, how much it stores, what is the energy use, and so on. Here we go. So what is it? It's an industrial facility that pulls carbon out of the atmosphere, uses a chemical process to filter it, then pipe it and store it underground, usually in saline aquifers. Right now around the world, there are 5 of them that are over 1,000 tons a year of removal. In Iceland and in the United States, there are 130 planned around the world. And here in the United States, there's a tax rebate for $180 a ton to incentivize them being created around the world, or here in the US. Okay, here's how to simulate it in En-ROADS. On the left, pull up under CO2 removals, sources of anthropogenic CO2 removals. It shows 6 different types here. On the right, I want you to look at the overall price. Down here at the bottom, under financial, cost of direct air carbon capture and storage. The slider lives under carbon dioxide removal, technological. Click on the 3 dots, use detailed settings, and then you can see you can set a subsidy, dollars per ton captured. I mentioned the US bill was at $180 a ton, but you can see up here the cost that we've assumed, and you can change this assumption, is that it costs around $650 a ton. I'm going to test 5 times or so the overall US subsidy, and we're going to change it all the way up here to the maximum in this slider, which is 1,000. Here it is. Boom, $1,000. Okay. So we watch it play out. You can see how much gets removed grows up to 200 by 2080. They're about 1 gigaton a year. 1 gigaton a year. There are a bunch of estimates that are out there. Others, so the IPCC scenarios was about the same amount, 1 gigaton a year. IEA, most ambitious, was around 3 gigatons a year by 2100. The Shell Horizon, more optimistic, at 5 gigatons. And NGFS, the integrated assessment models there, did not include DACCS at all. So you can see that our baseline with this at its max is somewhere in the range of other scenarios, around 1 by the end of the century. Why is this happening? Why is it not growing more? You can see over here, here's the price, and you can see that the price is coming down due to the progress ratio and the learning curve, but is not coming down as much as it would need to get a whole lot more growth. One little thing to notice is a little bump there. That's because of the large amount of energy use from DACCS, increasing energy prices a little bit and making DACCS a little more expensive before the learning curve effect kicks in and it gets much cheaper. This is such a small industry. We don't know how big it could grow. Therefore, it's very dependent on assumptions that we make about its growth and its prices into the future. So I encourage you to look under assumptions, scroll down to direct air capture, carbon capture and storage, and I'm going to focus on 2 most important assumptions. One of them is the strength of the positive or reinforcing feedback loop that we call the economies of scale, driven by the progress ratio. Here you can see that the progress ratio is 0.9. That is, every doubling of cumulative installed capacity brings the price down 10%, or 1 minus 0.9. Carbon capture and storage for gas and coal is 0.95. This is a little more generous. That is what's driving this cost down. Now, some other analysts think this price should be down here, down to $350 a ton is a major study. And we can explore what it would take with a progress ratio if it was 0.89, 0.87, 0.85. It would have to be much closer to the wind and solar progress ratio, which is 0.8, in order to get down to some of those prices that others imagine. Still, others promise $100 a ton, which really requires very, very ambitious progress ratios. The other way to imagine more growth and cheaper or more growth is a different estimate of the DACCS market at cost parity. As you can see in the assumptions, we have calibrated this to match the IEA's World Outlook Net Zero scenario. That is, when the subsidy equals the cost, then you get the IEA's scenario for growth. This could be higher. So you could explore assumptions where this goes all the way up to Shell Horizon if that assumption is different. So you can explore very different dynamics. Other factors to look at. One of them is the energy used. Under CO2 removals, energy used to capture and store carbon here in exajoules per year. Another one is the necessary transport and pipeline capacity. Here we can see in trillion cubic meters per year how much is needed relative to the global natural gas pipeline capacity. Another important factor is the total annual cost. Under financial, how much money is being spent to capture and store carbon here in billions of dollars per year. And one could compare this to the GDP of various countries or the size of the overall offset market in various ways to get a sense of perspective here. And the final is the storage leak rate. I'll have you notice that the total removals here is actually larger than what is captured in the long term, or different from what's captured in the long term. And I'm going to go and look at overall removals by different sources. Not sources of anthropogenic removals, but here, captured by source. Here, CO2 captured by 2080 is 1.3. Here it is as 1. This is affected by the energy used. More is actually captured than you get credit for as removals, because it takes a lot of energy that is driven by burning coal and gas that ought to be subtracted. So here we've subtracted the additional energy use and the emissions from that energy use, so it's lower. This is also affected by another assumption in the model. If you go under carbon dioxide storage, CO2 storage leak rate, we don't know how much leakage there could be from those saline aquifers and other storage. So if it's higher, watch as the benefit gets reduced. If it's as high as 3% a year, then we don't get as much permanent storage. But our base assumption, default assumption, is that it's 0. All right, DACCS and En-ROADS. We can see how big the industry is going to grow under different assumptions. We can see what it does to help the climate, and then some of these other systemic factors. I hope this is useful. Go get them.